We are starting with the water purification methods. As the title indicates, it means what are the different methods used for purification of water. There are a number of different methods are there, and mainly we can find three different approaches in water purification, which we call as primary treatment, secondary treatment and tertiary treatment. Primary means the first level of treatment. Second, then after that we are again treating, and tertiary is the more refined last method of treatment is known by the name tertiary treatment. So in a more technical term, primary treatments involves removal of physical contaminants, and mainly by screening, multimedia filtration and membrane filtration. For example, if the water containing large particles, maybe some plastics or some plant organic particles, all this has to be removed for making it pure for drinking. So that approach is known by the name primary treatment. Now in the case of secondary treatment, we will be removing whatever suspended solids mainly by biological methods, which we will see. And tertiary treatment mainly refers to the disinfection of water, so that all the microorganisms will be killed. And we will examine this in detail. The first one is the primary treatment. So in case of primary before the primary treatment, you can also see that there is a term called preliminary treatment. Preliminary treatment and primary treatment are sometimes combined, sometimes they will be separate. So in the case of preliminary treatment or the primary treatment, the coarse objects like rags, paper, plastics, metal that prevent damage to the water pipes or apparatus will be slowly removed. That process is mainly done by use of some screen. Here you can see that. So by using these kind of screens, we will be able to remove very large objects, mainly plastics or rags, etc., or very big paper, cardboard, etc. All this can be removed by using this kind of metal screens. So that is a technique that we are using in terms of here, and the screen can be divided into two different types. One is a coarse screening. This kind of a larger screen, mainly designed for removing larger sized object or large sized object, are known as coarse screen. Then there is fine screens are the fine screens will be the pore size, the hole size. This hole size will be very small, so that very small objects can also be removed. Here in case of fine screen, the pore size, pore means hole size will be 1.5 to 6 millimeter. That will be the size of the holes in a fine screen. But in a coarse screen, it will be appearing almost like this. Now, another technique that we are using in the is known as the multimedia filtration. So that is also coming under the primary treatment. So coming to the multimedia filtration, you can see that an apparatus like this will be used, or very large machines will be used. It is a modern physical wastewater treatment method which used 3 layers of filtration. Here you can see that this is the one layer, second layer, third layer, and these are the 3 primary layers. 3 layers of filtration media. Filtration media means substance used for filtration. For example, here you can see sand. Sand is a filtration media. Then you can see anthracite, a type of coal. It is also a filtration media. Then you can see gravel. That is also a filtration media. So if you look at this picture, you can say this is one layer combined. This is second layer, third layer. So here 3 layers of filtration media, such as anthracite, sand and garnet will be used, and the purpose is to eliminate water contamination. So that is the aim. In this wastewater treatment process, particle having size of 10 to 15 micron in size can be removed. So advantage of multimedia filtration is that very small particles. See here the size of the particle, if it is less than 1.5 millimeter, it may not be able to be removed by this mechanism. But here what we are saying is that even if the size of the particle is 10 micron, 10 micron means 1 by 1000 of a millimeter is 1 micron. 1 millimeter divided by 1000 is 1 micron. So even if it is less than 10 up to the size of 10 micron, we will be able to remove it by multimedia filtration. And multimedia filtration does not eliminate microbial contamination like bacteria, virus, fungi and other organisms. So most of the physical contaminants can be removed by multimedia filtration, but the smaller particles like organic particles or biological organisms like bacteria or viruses, they are very small. They cannot be, they are smaller than 10 micron. So they won't be removed by this kind of method known by the name multimedia filtration. If there is a picture of multimedia, video of multimedia filtration, I will show you. See, this is how the multimedia filtration is normally going on.
ഈ ഓണത്തിന് മൈജി മൊബൈൽ ഫോണുകളുടെ മാസ് കളക്ഷൻ, മാസ് വിലക്കുറവ്, സൂപ്പർ
It's a small video. You can see that how multimedia filtration will be conducted here. This kind of very large cylinders will be used and they will be containing these 3 layers of filtration media. This is some ad or something, but the main idea they will be showing. So this is how the mechanism is working. See, 3 layers are there. So gravel and sand, then is liquid. See, this is how the entire structure is working. 3 layers of filtration media will be used and they will be filtering it. So anthracite, dolomite and gravel. Or we can use different combinations are there. Okay, so this is an idea regarding what are the different types of multimedia filtration, and I am stopping it here. So that is regarding the multimedia filtration. Now another technique is known by the name membrane filtration. So here you can see that the first treatment known as screening, multimedia filtration, and third type of method is known by the name membrane filtration. It is also a part of primary treatment of water. Now you will see how this membrane filtration of water is being conducted. So here in this membrane filtration, the physical waste water treatment eliminates the water contamination with the help of a membrane. So that is the main idea. We are using a membrane, and the membrane will be having different pore size. So if the membrane size, one is known as a microfiltration. The pore size of the membrane will be 0.01 to 10 micron. So based on the size of the membrane used for filtering water, we can call it as microfiltration, where the pore size is between 0.01 to 10 micron. Then if it is size is between 0.5 to 0.01 micron, we call it by the name ultrafiltration, still more efficient method of filtration. Then another is known as nanofiltration, where the pore size will be very small, very tiny, 0.00, 0.5 to 0.1. So very fine particles can be easily removed by nanofiltration. For example, even if we can also remove ions like calcium ions. So that is possible in case of nanofiltration. And another technique that we are using is reverse osmosis. Pore size will be 0.005 to 0.0001 micron, so very small. So reverse osmosis can remove dissolved ions, bacteria, viruses and other contaminants. Sometimes when you go for purchasing a water purifier, they will say RO, and when they put RO, the price becomes more costly. Instead of 6,000 or 7,000, they say 15,000. So the difference is huge. So RO is more efficient because it will be able to remove ions, bacteria, viruses and contaminants. So that is the advantage of reverse osmosis technique. So here you can see that how the technique is working. So this is the reverse osmosis membrane structure. So what they are doing is that, see, they will have a water pipe like this, a main water pipe, and they will have a membrane called reverse osmosis membrane. So water will be going under very high pressure, and water is going under high pressure. Some of the water will be coming out of these holes, and they will be going through this membrane, and the remain that water coming out of the membrane will be collected. So that is the main idea regarding the reverse osmosis purification. So here you can see that this is how the structure, the technical detail of how a reverse osmosis system is working. This is a very highly expensive method of water purification, and so very costly also for establishing this kind of large scale reverse osmosis water purification. It will be very costly, and we will see if there is one video regarding that. Yeah, here there is a 2 minutes video. You can see that.
Hi, I'm Chaka, Director of Global Product Management for Drinking Water at Culligan. I'm here to tell you how reverse osmosis water filtration under your kitchen sink or sometimes in your basement. Unlike single-use plastic bottles or filter pitchers, with an RO system you get virtually unlimited filtered water right from your kitchen sink. The types of filtration included and how many stages there are is customizable based on your water and your needs. So how does this work? There are typically 4 or more stages of the process, which starts by filtering the biggest particles and works its way down to components as small as a single atom. Most ROs start with a sediment filter, which targets issues like rust, sand, and other large particles that may be in your water, whether you can see them or not. Next is carbon filtration, which reduces bad taste and odors. Chlorine is one of the most common causes of these problems. This is followed by reverse osmosis. This process uses an advanced membrane to separate contaminants as small as a single atom from the water. These could include heavy metals like lead, mercury, and chromium. After this, additional specialty filtration stages can address contaminants not covered in the prior steps. These could include organic compounds such as pharmaceuticals, viruses, bacteria, and more. If contaminants like these are a concern for you, look for an RO system that's third-party certified for the reduction of specific contaminants. For example, Culligan offers reverse osmosis systems certified to reduce as many as 60 different contaminants.
That gives you an idea of how the RO system is actually working. Now we move to another, that is what are the different steps in water purification. So this is the primary treatment. Now if we go to the another about 4 different steps in water purification, that is known as a coagulation, sedimentation, filtration, disinfection and storage. For example, you go to Kerala Water Authority, they will be following these 5 steps. So first step is known as a coagulation. In case of coagulation, they will be adding alum. Alum sometimes you might have seen. Alum is a white, kind of, this is called alum. It's kind of hydrated sulfate of aluminum. This is the alum. And I will show you a picture of how alum will be appearing. So this is the alum. Sometimes you might have earlier, this alum was used in barber shop for so that the skin becomes more smooth after a shaving. Nowadays it is not so common. So this is known as the alum hydrated aluminum sulfate. So this hydrated double sulfate of aluminium is actually used in water purification. So they will be added to water, and alum and other chemicals are added to water to form tiny sticky particles called phloem, which attract dirt and other particles suspended in water. See here, you can see that. Please keep quiet. So in case of this coagulation, what they are doing, they will be collecting water in a tank, and into that tank they will be adding this alum. Okay, and after as a result of adding of alum, what happens is that there will be sedimentation. See, when alum is added into the water, what happens is that smaller particles will be sticking together and become larger particles, and larger particles will be settling to the bottom of the tank, and that can be easily collected. So what alum is causing is that they will be causing sedimentation of the water, impurities in the water, and as a result of sedimentation, these larger impurities will be settling to the bottom of the tank, and from there which we will be able to easily remove it, and we can also take the clean water above that. So that sedimentation is actually caused by alum. So heavy flock particles settle to the bottom of the treatment plant, allowing for their separation from water. Then next one is the filtration. സാധാരണ നിങ്ങളുടെ ബാച്ചിലുള്ള പിള്ളേരൊന്നും സംസാരിക്കാൻ കണ്ടിട്ടില്ല. നിങ്ങളാണ് വിചിത്രമായ സ്വഭാവങ്ങൾ കാണിക്കുന്നത്. ബാക്കി പിള്ളേരൊക്കെ വളരെ ശാന്തരായിട്ടിരിക്കണം. അപ്പോൾ നിങ്ങൾ സത്യം പറഞ്ഞ ഒരു 10 വർഷം മുമ്പ് കോളേജിൽ പഠിക്കേണ്ടവരാണ്. ഇപ്പോഴത്തെ ജനറേഷൻ്റെ ഒരു ട്രെൻഡ് അല്ലേ ഇത്. പണ്ടത്തെ പിള്ളേർ ഇങ്ങനെ ക്ലാസ് എടുക്കാൻ നേരത്തെ അവർ ഇഷ്ടംമാരെ സംസാരിക്കും, ഞങ്ങൾക്ക് കുറേ നേരം അവരെ അടക്കി ഇരുത്തിയിട്ടാണ് ക്ലാസ് എടുക്കണം. പക്ഷെ ഇപ്പം അങ്ങനെയല്ല, ഇപ്പം പിള്ളേർ ശാന്തരാണ്, ആരും അങ്ങനെ സംസാരിക്കുന്നതായിട്ട് ഞാൻ ഈ അടുത്ത കാലത്തൊന്നും കണ്ടില്ല. അതുകൊണ്ടാണ് നിങ്ങൾ കാലം തെറ്റി ജനിച്ച ഒരു ജനറേഷനായിട്ട് എനിക്ക് ഈ 3-4 പേര് കാലം തെറ്റി ജനിച്ചവരായിട്ട് എനിക്ക് തോന്നുന്നത്. ഒരു 10 വർഷം മുമ്പ് കോളേജിൽ പഠിക്കേണ്ടവരായിരുന്നു എന്നാണ് എനിക്കിപ്പോൾ തോന്നുന്നത്. അപ്പോൾ നിങ്ങൾ വൈകിപ്പോയി, ജനിച്ചപ്പോൾ വൈകിപ്പോയി, അതുകൊണ്ട് കുഴപ്പം. നിങ്ങൾ ചെയ്യുന്നതിലുള്ള പ്രശ്നം. 10 വർഷം മുമ്പായിരിക്കും ഇതൊക്കെ പെർഫെക്റ്റ്ലി ഓക്കെയാണ്. പക്ഷെ ഇപ്പോൾ ഇത് ഇങ്ങനെ ആരും സംസാരിക്കുന്നതായിട്ട് കണ്ടിട്ടില്ല ആരും, അതുകൊണ്ട് ഞാൻ പറഞ്ഞു. സോ നെക്സ്റ്റ് വൺ ഈസ് ദ filtration. The water passes through filters of sand, gravel and charcoal to help remove even the smallest. So here you can see that the first step is coagulation, then comes the sedimentation, then comes the third stage. Third stage is known as a filtration. So in case of filtration, you can see that the water will be fitted in 2 or 3 tanks. At each tank, different type of filtration media will be used. Water will comes here, and it will be passed through a filtration media, and the bottom water, filtered water will be taken and will be again pumped to another filtration tank. Then again another material will be filtering it. Again this process is going on. So 3 types of water tanks will be used for filtration. So as a result of filtration, see, we will be using sand, gravel and charcoal. This is sand, gravel and charcoal. So these kind of different materials are used for water filtration, and as a result of filtration, most of the impurities, most of the dirt in the water may be completely removed. Then even after that, there will be microorganisms. Earlier you can see that even if you are using reverse osmosis membrane, the size is 0.0001 micron, but it is still larger than the size of the most bacteria. So bacteria and viruses can easily come through even if you are using reverse osmosis. So what we have to do is that we have to go for disinfection. And in case of disinfection, our purpose is to destroy or kill almost all the microorganisms. So most of the time we are using chlorine. Chlorine is the most common type of disinfectant because chlorine can kill most of the microorganisms. So that step is known as a disinfection. For disinfection, other than chlorine, we are also using ozone, we are using hydrogen peroxide. So other types of chemicals are used, but most commonly we are using chlorine because chlorine is less expensive. Another advantage of chlorine is that chlorine can remain in water for a long time compared to the ozone or other type of chemicals. So that using chlorine has an advantage. So even after disinfection with the chlorine, there will be little chlorine in that water for several weeks. So that is an extra added advantage for using chlorine. So after disinfection, we will be collecting water in the water tank. Now we will see how this disinfection with chlorine is actually conducted. Here the idea is again, so water taken here, we are adding coagulant. Then as a result of coagulation, larger particles will be settling, and this kind of fan will be there, and there will be filtration, there will be disinfection, and after disinfection the water will be stored in a finished tank, and there will be supplied to water tank. So last time we have went to Kerala Water Authority water treatment plant in Alua. If possible, you will have one IV like that. So we may have to go maybe in September or October. We will try to go to see that water treatment plant and some more other topics related. Then, and as far as your syllabus, you have to visit one health center. So most of the time we will combine this health center visit and this water treatment visit. If possible, we go. Then next idea is regarding the chlorination, and I think we will see some videos on this water treatment process. So this is normally the you will see this is a 10 minutes video, so that you will have a better idea.